Find I for t greater than 0 if the initial value of V is 6 volts. This is the drawn figure. Applying KCL here, node X, and the current in 6 ohms is supposed A, while in the 3 ohms is B. And the current in the unit of capacitance 1/9 farad is dI. Solution: KCL at node X. The summation of current entering is equal to the summation of current going down. So 0.5I plus A equals I plus B. So rearranging the equation. 0.5I equals A minus B, and I is the derivative of Q with respect to T. So 1/2 derivative of Q with respect to T equals A minus B, and that is now the equation 1. Applying KVL here for loop 1 and loop 2. So KVL at loop 1. Negative 6A minus Q over 1/9 is 0. Negative 6A minus 9 times Q is 0. So A is 1.5 times Q. And that is for equation 2. And now for KVL at loop 2. Q over 1/9 minus 3B is 0. And B is 3 times Q, and that is for equation 3.
Now that we have our 3 equations, let's perform a simple substitution. Take our expression for A and B from equation 2 and 3 and plug them right back into our KCL equation. We get 1/2 dQ over dt equals to negative 1.5Q minus 3Q. Simplify 1/2 dQ over dt equals to negative 4.5Q. Then dQ over dt equals to negative 9Q. Now that we have the answer to substituting equation 2 and 3 to equation 1, now let's proceed to solving using variable separable. Integral of dq over dt equals to integral of negative 9q. Integral of dq over q equals to integral of negative 9 dt. Integral of dq over q equals to negative 9t plus c. Move the q to the left and we get 1/9 times 6 equals to 0.667, or q is equal to KIE negative 9t. Finally, to find the current I of t, we just take the derivative of the charge. Differentiating 0.667 E 9t brings down that negative 9 from the exponent. Then I is equal to dq over dt. So our final answer for the current is I is equal to 0.667 times negative 9 times E negative 9t is I equals to negative 6E negative 9t amperes. And that's it for problem 8.7. Quick and easy. If this helped you out, don't forget to like and subscribe. See you in the next one. Goodbye.